Hello dear students of 10th class. First of all, welcome you all on my YouTube channel, Physics Concepts and Motivational Talks. So today's topic is refraction of light. So first of all, what do you mean by refraction of light? Now, when a ray of light enters from a rare medium to denser medium, it bends toward the normal at the point of incidence. And when ray of light enters from denser medium to rare medium, it bends away from the normal. In both the cases, ray of light bends towards or away from the normal when it enters from one medium into another medium. So this phenomenon of bending of a ray of light either towards the normal or away from the normal at the point of incidence when it enters from one medium to another medium is known as refraction of light. In other words, so the path or direction of ray of light changes when it enters from one medium to another medium. So when it enters from a rare to denser medium, it bends toward the normal. Therefore, angle of incidence is greater than angle of refraction. So in this case, R is less than I. Angle of refraction is less than angle of incidence. On the other hand, when it enters from denser to rare medium, it bends away from normal. So angle R is greater than angle I. So path or direction of ray of light changes when it enters from one medium to another medium, and this phenomenon is known as refraction of light. Now, there are two laws of refraction of light. Number one, the incident ray, the refracted ray, and the normal all lie in the same plane. This is the first law. Second law, the sign of the angle of incidence, T ratio, sign of angle of incidence to the sign of the angle of refraction. It is always constant, and this constant is known as refractive index of the medium. So this law is known as Snell's law. So there are two laws of refraction. One is incident ray, refracted ray, and normal all lie in the same plane. Second, the ratio of sign of angle of incidence to sign of angle of refraction is always constant, and this constant is known as refractive index of the medium, and this is known as Snell's law. Now we have to draw ray diagram for refraction through a glass slab. So what is glass slab? Glass slab is a rectangular piece of glass which has two parallel sides. Now suppose this medium is A and medium A is surrounding the glass slab. So there are two media, you can say. First of all, at the upper face, let a ray of light OA enters at O. Let I is the angle of incidence which the incident ray makes with the normal is called angle of incidence. Then it bends toward the normal, that is making R angle of refraction less than angle of incidence. Then at next boundary, so separate the two media, glass slab and air, that is at O dash. Again, light gets refracted, it bends away from the normal because now it is traveling from denser to rare medium. So let this angle is E, and this angle E is known as angle of emergence. So this is the path of ray of light when it passes through a glass slab, that is when it gets refracted through a glass slab. I is the angle of incidence, R is the angle of refraction. Now for point O dash, this R becomes the angle of incidence because these two angles are equal. So R becomes the angle of incidence and E becomes the angle of refraction, and it is known as angle of emergence or refraction through glass slab. Then by applying Snell's law at point O first, what is Snell's law? Ratio of sin I upon sin R is equal to constant. So we have mu AB. So mu AB means because rays traveling from medium A to medium B. So this gives refractive index of medium B with respect to medium A. So mu AB is equal to sin I by sin R. This is equation number 1. At O dash, again by applying Snell's law, because light is entering from medium B to medium A. So mu BA is equal to sin R, because R is the angle of incidence for this interface. So sin R upon sin E. E is the angle of refraction and it is known as angle of emergence for the glass slab. This is equation number 2. So if we multiply 1 and 2, so we have mu AB into mu BA is equal to sin I by sin E. But mu AB into mu BA is equal to 1. Because the reciprocal of medium B with respect to medium A, refractive index of medium B with respect to medium A is equal to the reciprocal of refractive index of medium A with respect to medium B. So 1. So sin I is equal to sin E or I is equal to E. It means when a ray of light passes through a glass slab, angle of incidence is equal to angle of emergence. I is equal to E. It means incident ray and the emergent ray, they are parallel to each other. So this is all about the refraction of ray of light through a glass slab. So you remember angle of incidence equal to angle of emergence when ray of light passes through glass slab. In other words, incident ray and the emergent ray, they are parallel to each other. It means if there is no glass slab, the incident ray should go like this. So emergent ray and incident ray are parallel. So I ray and E ray, incident ray and emergent ray are parallel to each other. Now, as we have studied by Snell's law, ratio of sin I by sin R is equal to refractive index. Now, if you have to define absolute refractive index of a given medium, the glass, water. So, absolute refractive index of a medium is defined as the ratio of velocity of light in vacuum to the velocity of light in that medium. Because velocity of light in vacuum is always constant, which is 3 into 10 to the power 8 meter per second. And velocity of light in medium is always less than the velocity of light in vacuum. So mu is equal to C upon V. This is known as definition of refractive index, or it is known as absolute refractive index of the given medium. That is refractive index of a medium with respect to vacuum or air or free space is known as absolute refractive index. And when we have to calculate refractive index of medium B with respect to medium A, then it is known as relative refractive index. So absolute refractive index is given by C upon V. So for glass, ordinary glass, it is 1.5, and for water, absolute refractive index is 1.33, or you can take 4 by 3, or refractiveness of glass can be taken as 3 by 2. 1.5 for water, 1.33. For a given pair of media, mu AB, when light is traveling from medium A to medium B, that is refractive index of medium B with respect to medium A. It is defined as the ratio of velocity of light in medium A to the velocity of light in medium B. And mu BA is refractive index of velocity of light in medium B to the velocity of light in medium A. If you multiply these two, mu AB and mu BA is equal to 1, or mu AB is equal to 1 upon mu BA. We have already taken mu AB into mu BA is equal to 1. That is refractive index of medium B with respect to medium A is equal to the reciprocal of the refractive index of medium A with respect to medium B, and it is known as a relative refractive index. So this is all about the refraction of light, laws of refraction of light. What is refractive index? Refractive index has no units, it is dimensionless, and its value for a given medium is always greater than 1, and refractive index of free space or vacuum is equal to 1. So this is all about refraction of ray of light and laws of refraction and about refractive index of the medium. Now In next video, I will discuss refraction through spherical lenses, convex lens and concave lens. So to make the short video so that you can understand step by step, so I prefer small videos and small topics. So be happy, ਇਸ ਤਰ੍ਹਾਂ ਪੜ੍ਹਦੇ ਰਹੋ, ਨਾਲ ਜੁੜੋ, ਆਪਣੇ ਜੇ ਮੇਰੀ ਟੀਚਿੰਗ ਵਧੀਆ ਲੱਗਦੀ ਹੈ ਆਪਣੇ ਦੋਸਤਾਂ ਨੂੰ, ਆਪਣੇ 9th ਤੋਂ ਲੈ ਕੇ 10th 11th 12th ਸਾਰੇ ਕਲਾਸ ਜਿੰਨੇ ਤੁਹਾਡੇ ਨੋਨ ਸਟੂਡੈਂਟਸ ਨੇ, ਦੋਸਤ ਨੇ, ਉਹਨਾਂ ਨੂੰ ਕਹਿ ਕੇ ਮੇਰਾ ਚੈਨਲ ਸਬਸਕ੍ਰਾਈਬ ਕਰਾਓ ਔਰ ਉਹਨਾਂ ਨੂੰ ਬੈਨੀਫਿਟ ਹੋਏਗਾ। ਮੈਂ ਚਾਹੁੰਦਾ ਕਿ ਵੱਧ ਤੋਂ ਵੱਧ ਸਟੂਡੈਂਟਸ ਨੂੰ ਮੇਰੇ ਵੀਡੀਓ ਦਾ ਬੈਨੀਫਿਟ ਹੋ ਸਕੇ, ਘਰੇ ਬੈਠੇ ਤੁਸੀਂ ਬੈਨੀਫਿਟ ਫ੍ਰੀ ਦੇ ਵਿੱਚ ਲੈ ਸਕੋ।